Thank you for watching. Today I have in the bench for repair for a customer a pair of high-end tube amplifiers. These are the Esoteric Audio Reaserch amplifiers. The tube set is a PL509. I think the model, I couldn't get too much information of these amplifiers online, but I think the model is 509 as the tube. So it's a couple of Esoteric Audio Reaserch monoblocs. The problem with these units is that they have been serviced recently by another technician. All the coupling capacitors and the interstage capacitors were replaced, and that was due to red plating existing on the amplifiers. The amplifiers seem to work okay, but there was red plating on the tubes and they didn't know how to solve the problem. So what I did was to suggest replace not all the capacitors, but what I did was to check the schematic and suggest which capacitors and which type of capacitors to acquire to replace those capacitors. And that was the only thing I could comment on what to do without having the units myself. I don't know if the job, how well it was done, but the issue now, the owner got the amplifiers back from this technician, but one of the amplifiers, this one of the monoblocks, this one, is distorting. It's not sounding correctly. The process I will do now is to open the units. I've opened one of them to see what's inside. These amplifiers were manufactured in the 70s, I believe. They are quite old, but they seem to perform really well, and I think they are very sought after. So I don't really know. I don't know the brand. I attribute the really good audio performance on the way the output transformer is designed and implemented, and all the output stage, how it's implemented together with a very special audio transformer. I remove the bottom cover, and as you can see, these are like really handmade, very handmade. This is the output transformer. This is where the electrolytic capacitors of the power supply are connected, which these go into this metal case. Another thing I've noted is that on the pictures you see online, the electrolytic capacitors are exposed here. There you see 4 electrolytic capacitors. So they build this cage to cover the small electrolytic capacitors, the new ones, which are small in size and really don't look really appealing. And also you can see this board, which has some sort of, it says something like in reverse. This is not something of the video. It's written in reverse like Gotham Audio or something like that. Maybe this is a board which was added by the same service people that replaced electrolytics. This is a homemade board, of course, I could manage to get some pictures from the underside of these amplifiers online, and this board is not present. The electrolytics are wired directly to the leads of each capacitor. So this board was added. You can also see how these amplifiers really look, let's say, handcrafted. You see that the board here is the layout is all handmade. Also you can see EAR 509. This is handwritten in the etching of the board. So everything is handmade. There are some details like the clearing here between the metal chassis and the traces on this board is really minimal. This is really worrying to me. In fact, the service person that worked on this before me had put some sort of isolating pad here. I think I have it here. This is like an isolating pad which was loose there when I removed, and they also added only in one of the amplifiers, and they also add some sort of washer here to try to avoid the screw touching the trace on this board. So I think this has to be addressed before returning these amplifiers. And as you can see, these are all the caps that were replaced by the technician before me. These are the caps that I suggested he replaced, and these are the model I suggested him to buy, which are this Illinois capacitor type, that work very well. And Nichicon electrolytics. There are some other things that were replaced here, as you can see. Some resistors that are two resistors in series. I don't know if you can see there. Two resistors in series. Maybe they needed a special value and they couldn't get it. But anyhow, have to check this out. I also noticed with some pictures on the internet that this input and the output binding posts is not original. It seems to be here some sort of acrylic. I think it's acrylic. Yes, a piece of acrylic here that now supports these three binding posts. In the original amplifier, these are much smaller, and I think there are 4 of them. One is chassis ground, and the other 3 are from the output of the transformer. One is, I think it's common, and that's 4 and 8 ohm. If you rewire the transformer, you have a combination for a 16 ohm speaker. But then we will check that with the schematic, and we'll figure out what's going on here. I think the chassis is already connected to this common binding post. I don't know what happened here. This has to be also addressed. This is the power transformer, and as you can see, these here are the rectifiers. So these are 2 rectifiers, and here are 2. Let me see where there are the other 2 rectifiers, diodes, and I think this forms a bridge rectifier. I have to check that with the schematic, and which goes to the positive of the amplifier, and I think the other side goes to the negative. I think through this little red wire is this same little red wire, or something. I don't know. I have to check that with the schematic. But as I was telling, this is the output transformer, and this is like the heart. Not the heart, sorry, but this is. I think this is what makes the magic of really good audio performance. There are many windings here in the transformer, which some coupled to the output tubes directly on the plate, some coupled to the screen of the tubes. So I think the way this is implemented, what makes the magic of this amplifier, as I've already said. But some things that I don't like very much, but that's a personal opinion, is the craftsmanship here. Some things could have been better, like the chassis, as I already told, and some of this wiring and some details here maybe could have been done better. And here I have the other amplifier, which shows, well, similar, not exactly the same, I'm seeing that there's some differences, small differences here. Not very many, but for example, they should be identical, but we have these two capacitors here, set of capacitors here, and here we have only one. And here we have this capacitor which was replaced, and here we still have this one, and the rest looks the same, but I will check. Well, I spoke to the customer and I started checking each of the amplifiers. I have both of them side by side, and as you can see, I remove the boards, but they are still all connected to each other, to see the extent of the repair on each amplifier. As mentioned before, here's one capacitor which is missing, and the replacements, for example, on this one, these were made on this side, while on this amplifier they are not here, they are on the underside of the PCB. That's okay. In my opinion, you should do both amplifiers the same way, but it works. They're all there except, I think, for this electrolytic capacitor, which is not present here. So I don't know what's that. I have to check the schematic. Also, I can see there's these amplifiers went through many repair stages at different times, and clearly I guess all these type of resistors are the original ones. There also happens that I've been measuring many of the values of the resistances and everything, and they don't seem to be okay, so I don't know. Then also we can see there's a lot of dirt from the decades here. Nobody in all this time decided to clean all this. I don't know why, because they made all this work, but they haven't cleaned that, and they also didn't clean the flux residue. They're really a mess. These boards are all a mess, and we have these things, these resistors flying around. This is horrible. So what I spoke to with the customer, look, these capacitors are different than these ones, at least in the brand. These have been replaced. These have been replaced too, but with different model ones. So in a look at this resistor here, there. So in an amplifier of this, look at all the hot glue here melting down. I don't know. In an amplifier of this category and price points, even though it's a really old amplifier, has many decades, it's a very valued amplifier. So I think that what has to be done here, and I spoke to the customer and he agreed, is that I will start board by board. I will remove this board completely, and I will work on it until every component is checked and it's clean and it corresponds to what the schematic says, and then I will continue with the next one, and with the next one, and with the next one. And once everything is checked and verified, then I will test everything to see if the amplifiers are working, because I think it's the only way to be sure that everything has been done correctly. On the other hand, if there is a problem, the problem that makes the amplifier distort, that problem will most probably appear when I go through each component of the board. So that's the plan. The plan is to go board by board and check every component there. Okay, I started removing all the capacitors that were added I mean, they were replaced on the boards of the amplifiers, but the job was done. I don't know. It was a very messy job, and it also some things differed from one amplifier to the other, and it also was different from the schematic itself. So there were some 0.1 capacitors added in parallel with the electrolytics that they are not present in the schematics. I don't know. It's because it's something that the previous tech decided to add as a high pass filter. I don't know. I have to check the schematic to see what he intended to do. Sorry for the bad lighting here. So I removed as you can see, all the electrolytics and capacitors that were placed here, and I removed the board. I will do this process with all the boards. There are 2 boards per amplifier, so I will do this with the 4 boards. Also, they're still here. These are these resistors that are like 2 in series, and the PCBs were cut, the traces. I don't know if it can be seen there. The traces are cut. I will try to show it here. There is a cut here. Instead of the trace, they put a resistor, and there is a cut here. Let's see if it can be seen. So instead of the little trace there was a resistor. So there's what they did is it's a modification to the schematic, which is in this tube here, and instead of having this 33K from both cathodes to ground, they had this set up here. They had a 12K, and then a 23K to ground. So I don't know. I will take it back to factory design to see if everything works well, because I don't know what they tried to do here. I think they also some things seems to be added here. I don't know. These little potentiometers look to be added afterwards. I have to check all that, but I'll start removing everything that it's not original, and then I will thoroughly clean this and place the components as the schematic says and in the correct way. And I will do this with all the boards of the amplifier, and then I will assemble everything. So we have the amplifiers will be like as designed in the schematic, and not some modification that somebody did, I don't know with what intention. There's no documentation or anything, so I think the best way to proceed is to go as designed in the schematic, and then if there is something that has to be addressed, it will be addressed later. Here, this is one of the boards I cleaned, and as you can see, there's a difference between this board, which is all cleaned and really nice. It took a long time to clean. The board is here a bit overheated, but it's because it's very close to one of the output tubes, so but that doesn't affect anything. And on this side the board is very clean, very nice. I think I will replace some of the resistors here, but I've measured, for example, these resistors are okay, are perfect in value, so that won't be replaced. More on the reconditioning of the boards of the amplifier. As you can see, this board is mostly finished now. I've not only cleaned it, but also replaced all the capacitors, and also replaced all the components, all the resistors that were out of value. These resistors were replaced. Some of them were perfectly in their value, but others were have drifted or were with a lot of heat, so they were really crusty, and I replaced these mica capacitors too, 15 picofarad. I have to install one a missing one here. I just remember, and I have to install the biasing pots here. I also I've redone these trays and these other trays, which were the ones that they have interrupted there, to place all those resistors in series, so that it's as in the schematic I have. So that's been fixed. All the components and all the values now reflect what is specified in the schematic. I also redone the other board, the one where the output tubes go, and as you can see, the board is also cleaned and all the capacitors have been installed. The capacitors, I will put some cement, not hot glue, because I don't understand people that use hot glue to stick electrolytic capacitors to the board, to fix them to the board, because the heat of the hot glue damages the capacitor. So I don't understand. Sometimes people put some hot glue there and stick the capacitor, fix it to the board, and that's not good. I will put some other type of cement, maybe some epoxy or something, but that's after the amplifier is fully tested. So for now I will use it like this. So both boards, this one and the other one, are practically complete, and I have here the amplifier, which I'm starting to install them back to the amplifier and to make the first test on the first channel. Then I have to do all this work on the other channel. I was also inspecting the output transformer, and well, I have a schematic here which I've been using to do all the to check all the components, so it's all marked. But I've seen a small difference here in the output section. It's but that's not a modification, but it's that the traces are original from the board and differ a little bit from what's on the schematic, but it's just how the biasing resistor, it's not the biasing resistor, it's a resistor that's used to check the bias current. It's placed in a slightly different position than in the schematic, but that's all the little difference there is. I've installed the boards back in the amplifier and wired everything back together. As you can see, I've wired all the different wires that go to the output transformer. In fact, this wiring was connected through the underside of the board, and I decided to put it from the upper side so as to have it more accessible, and if I need to move the boards around for testing, I can do that. I also, as you can see, I powered it up. There wasn't any magic smoke, although this capacitor, which in the schematic was rated at 160 volt, and as you can see here it says 33 microfarad, 160 volt. I put a 250 volt there, and it's much higher voltage, so I immediately replaced it with a higher voltage 500 volt one. That's just for the moment. Then I will put it back together, all the very tidied up like the other ones. And also I've placed shorter standoffs here. As you can see, the original ones were very long, so there was practically no clearance between the board and the chassis, the bottom part of the chassis, which was very dangerous. In fact, there was like a piece of cardboard, something trying to isolate there. This was very dangerous. And on the other side of the amplifier, there's no problem there for the tubes to be a bit higher, so I decided to put some shorter standoffs there. And the other details I had to manage. In fact, This is the input connector. As you can see, it's floating around here because it had some, so it was in the hole there. It had some homemade washer. It should be isolated, but it had a wire washer which was like a disaster. I have to fix that also. So okay, the amplifier came on, and on the oscilloscope I can see a sine wave. So now I'm in the process of making the first tests on it. So I'm quite happy that everything is starting up properly. Let's see. Okay, I'm in the last phase of the assembly of these monoblock amplifiers, and at this stage I have all the boards complete. The 4 boards, 2 of it for each amplifier. These are the 2 boards of one of the channels, and there's the other channel has the other 2 boards. They are all fully and completed, fully checked. They have been cleaned. This is the underside. Every capacitor and every resistor has been tested. Those that were out of value have been replaced. Those that showed signs of heat and stress have been replaced for new ones. Some resistors are still original, like these ones, but they measure really good, so I won't replace them. Other resistors were replaced, like this one, to the value specified by the schematic and not the value that was present, like this one too. All capacitors, as you can see, all of them were replaced. In fact, the boards, the other 2 boards have been tested. I've connected the 2 boards onto one of the units and briefly tested it, and it works perfectly. It sounds really great, so I think this will perform really good. So those were tested, but they're not fully installed in the unit yet. There were as I was testing, I wanted to be sure everything was okay, but it started working really well, so I decided to complete this other pair of boards and go and assemble everything properly and test both units at the same time in the stereo configuration that I believe they will perform outstandingly. Yes, a couple of things. As you can see, maybe you can see here, I had to remove some of the trays here, and also in this board, specifically here, the trays went all the way through here, and it was a very small clearance to the screw there, and it was the previous technician installed like an isolating washer there. It was something that wasn't really it wasn't inspiring confidence, so I decided to remove the trace here and connect these 2 parts and make the path this way. And also here I removed part of the trace and went through the back because the clearance was very small there too. So I took care of that. Also, in the testing of the other board, this capacitor that in the schematic shows us 250 volt rated, voltage is higher here, so I decided to put a 500 volt rated capacitor, and those are the changes. So, well, I finished the work on the monoblocks, and we started making some tests. The customer listened to the monoblocks for a little while, and although they sound really good, he reported that one channel was sounding a bit higher than the other, or at least volume levels on the channels seem to be different. These amplifiers originally had a volume knob on the back to adjust the level on separately on each unit, but that was already removed from these units when I've got them. It seems to be right. Here's the scope that shows those traces, both the violet and the cyan traces are the both outputs of the amplifiers. They are both connected to a dummy load, and they are both fed from the exact same signal. This is 1 kilohertz signal, which comes from the generator, and they are both inputs connected in parallel, so it's the same signal. You can see that the cyan trace is higher, a bit bigger in amplitude than the purple one. So I will investigate into that. Okay, I believe that the two monoblock amplifiers are ready. Of course, I have to put all the tubes, and also I have to make the final testings, and I have to adjust the bias once more to the output tubes, because I have been moving around the tubes, and just before leaving I will readjust the bias. But other than that, I believe no other modification will be necessary. Regarding the little difference in gain between one unit and the other, I've been looking at the schematic, and I've been testing some of the resistors, especially the ones in the feedback loop, and they are all well between tolerances. So I think it's the difference in gain, it's something specific to the design, and that explains the level pot here, which makes a bit, in my opinion, makes no sense in an audiophile level amplifier to modify the level of each channel differently. But what I did is, first of all, is to measure this 100K resistor, and in both units there was a difference. One was like 101K and the other one was 99K. So coincidentally, the one that had less gain was the one that had 99K instead of 101. So what I did was to put in parallel a very high resistor here. I will show you, so that this resistor in both units has 99K. This solved the problem, because now when I look in the scope, both outputs of the units, they are exactly the same. So the amplifiers have the same gain and seem to be working fine. So what I did, I can show you here. In this small package, I had to put in series two. I think it was this. The total, I think it's like 4 meg in parallel with the 101K resistor. So this gives in total a 99K resistor, and that solved the problems of the difference in gain between the two units. I also put some glue on the different capacitors, so they're all glued down in the other unit, of course, as well. And also, of course, we bought some nice input jacks, RCA input jacks, and they're soldered in place. I had to make a bigger hole, a slightly bigger hole here to accommodate the input jack. So I think these two units are really nice. I will put everything back together. As I told you, I will test them and adjust the bias, and they will go to the customer as soon as possible. Thank you for watching this video, and hope you liked it.